How's it going, guys? Welcome back. This is the CIP2 study guide, part one of it anyway. And in this one, we're going to go over advanced corrosion mechanisms, how to identify them, the causes, and the various solutions. Again, this is for anybody going for their CIP level 2. I'm just going to try to cover as much of the advanced stuff, whatever I can think of. So if you want something specific, please leave a comment. But why study advanced corrosion? CIP level 2 goes beyond recognizing rust. You have to understand the different corrosion mechanisms, what causes them, and how they work, and ultimately how to prevent them or repair them. So this knowledge is going to be useful for anybody that's going to be dealing with this stuff. So you have uniform corrosion, which is usually it's evenly, like, it's grouped together. It's just a uniform look, like you can clearly see it was bare metal or too thin of a paint film. And here's some examples of that. This is basic CIP1 stuff, but as we get into the more advanced stuff, crevice corrosion, it's localized corrosion in shielded areas where stagnant solution is trapped, water under gaskets, lap joints, deposits. You'll be able to see it's usually like along weld seams or anywhere that gets pinched, metal's being pinched together. It's often left bare, and then this is what typically happens. These got distorted, unfortunately. Underfilm corrosion. Again, this happens from poor surface prep and poor application of the thickness of the film. You can see on this bottom one under example 8, you can actually see looks wet around that spot, and that likely is moisture or just corrosion, delamination of the primer underneath the top coat. So pretty interesting to see. Pitting corrosion. It's pretty self-explanatory, just deep pits, usually along pipes. And this shows pitting corrosion on a stainless steel substrate and the various chemistry that occurs. Galvanic corrosion is probably the most important one in my opinion, because that's what I see the most out in the field. Learn the galvanic series. They go over it in level 1, but I mean memorize it for level 2. Galvanic corrosion occurs when two dissimilar metals or more are in electrical contact with an electrolyte, or it doesn't even have to be. The electrolyte can be, if the humidity is high enough, it can act as an electrolyte, which is kind of wild. But the more active metal would become an anode and actually corrodes. So aluminum and stainless steel are extremely reactive, especially in saltwater environments. Even if just the threads from a single stainless steel bolt are making contact with an aluminum substrate, I'll show you what happens. But this is a common, very, very common thing. The paint can be perfect. It can be a perfectly applied paint job. If there's galvanic corrosion happening, it's gonna bubble the paint. It's gonna ruin the whole paint system. Oh, these were supposed to be videos. I'll see if I can add them or edit them. The other corrosion mechanism is MIC, microbiologically induced corrosion or influenced corrosion. corrosion that's accelerated by microorganisms, often in pipelines, tanks, ballast water tanks. To identify them, tubercles, localized pitting, often under a biofilm, biocides, proper cleaning, or treatment for it is biocides, proper cleaning, and then redoing the coating system. But this is just a little diagram that kind of shows what's going on with MIC corrosion. You can see some examples of the pipes, and it's pretty nasty stuff. And then another one that's really interesting is cavitation corrosion, which occurs on props, usually for marine vessels. From that turbulence of the water, it's actually creating like micro explosions where the air is actually it's vapor bubbles, or vapor bubbles that explode due to pressure differentials. And that little explosion actually does chip away at the props. It's pretty wild stuff. But yeah, those are the main corrosion types. Then I think there's a few others, but I'll provide more content on this stuff as we go. But some advice for guys going, people going for their level 2. Learn to recognize corrosion types. Always connect cause, effect, and solution in your answers. Use simple memorization tools like ACE, abbreviating, that kind of thing. Relate theory to practical inspection scenarios. And remember, identifying corrosion correctly can save millions in repairs. And for the next guide, I'm going to go over advanced testing methods. So we'll cover holiday detection, high and low voltage, soluble salt, conductivity testing, chloride testing, then adhesion testing, and probably ultrasound DFT measurements. So that'll be in the next one. So hope this helped you guys. If you want something specific, please leave a comment, and I'll do my best to get it out. So we'll see you guys in the next one. Thanks.